So how did we get where we are today? So here's a kind of short history of AI. Really, to put it in the simplest possible terms, AI looked like this. We had people who wanted to build these things, and they had dreams. They had dreams of these amazing robots. And the robots, they thought, they talked, they did whatever we wanted the robots to do, translate, play chess, whatever. And then they started to build. And really, at the beginning, it was like kids with Tinker Toys, really. The tools we had available were not adequate to realize our vision. And in a lot of ways, they still aren't. Okay? And so we had this grand dream, but very kind of limited in practice. And that really is the short story of AI. I'm now going to show you a documentary fragment. This is an excerpt from an old program called Nova. And this consists of a discussion from a modern perspective of what AI was like in the early days, say the 50s. And it's going to have interviews conducted a long time ago with a bunch of people, some of whose names you will recognize, who are amazingly smart people, predicting on the basis of the first few years of computation where AI was going to go. And now we can look back 50 plus years later and kind of think through what that meant and where we are today. So let's take a look.
The Thinking Machine.
Hello again. With me tonight is Professor Jerome B. Wiesner, Director of the Research Laboratory of Electronics at MIT. Dr. Wiesner, what really worries me today is what's going to happen to us if machines can think. And what interests me specifically is, can they?
Well, that's a very hard question to answer. If you'd asked me that question just a few years ago, I'd have said it was very far-fetched. And today, I just have to admit I don't really know. I suspect if you come back in 4 or 5 years, I'll say, sure, they really do think.
Well, if you're confused, Doctor, how do you think I feel?
We're just really beginning to understand the capabilities of the computers. I've got some film to illustrate this point, which I think will amaze you.
That man isn't playing checkers against a computer, is he?
Sure, and it plays pretty well.
Now, which color...
While most computer scientists saw it as a mere number cruncher, a small group thought that the digital computer had a much grander destiny. Being a general-purpose machine, it could be programmed to do things which in humans require intelligence, play games like checkers and chess, and solve brain teasers.
Let's see what it's turning up.
The field became known as artificial intelligence.
Can machines really think? Even the scientists argue that one.
I'm convinced that machines can and will think. I don't mean that machines will behave like men. I don't think for a very long time we're going to have a difficult problem distinguishing a man from a robot. And I don't think my daughter will ever marry a computer. But I think that computers will be doing the things that men do when we say they're thinking. I'm convinced that machines can and will think in our lifetime.
I confidently expect that within a matter of 10 or 15 years, something will emerge from the laboratories which is not too far from the robot of science fiction fame.
They hadn't reckoned with ambiguity when they set out to use computers to translate languages.
A $500,000 supercalculator, most versatile electronic brain known, translates Russian into English. Instead of mathematical wizardry, a sentence in Russian is to be fed in...
One of the first non-numerical applications of computers, it was hyped as the solution to the Cold War obsession of keeping tabs on what the Russians were doing. Claims were made that the computer would replace most human translators.
At present, of course, you're just in the experimental stage. When you go in for full-scale production, what will the capacity be?
We should be able to do about, with a modern commercial computer, about 1 to 2 million words an hour. And this will be quite an adequate speed to cope with the whole output of the Soviet Union in just a few hours computer time a week.
When do you hope to be able to achieve this speed?
If our experiments go well, then perhaps within 5 years or so.
And finally, Mr. McDaniel, does this mean the end of human translators?
I would say yes for translators of scientific and technical material, but as regards poetry and novels, no, I don't think we'll ever replace the translators of that type of material.
Mr. McDaniel, thank you very much.
You know, that was the 50s and 60s. That was the early days. In the 50s, people basically realized that you could do computation with circuits, and the brain was kind of a little bit like a bunch of circuits, so surely we were almost there. And then people got really excited, and this is basically what you saw in this video, that people, they got the computer to play checkers reasonably well. They got the computer to translate, or at least come close. What did that mean? It meant you looked up the words in a dictionary and you outputted them. Turns out there's a little bit more to translation than that, and so it was not the case that in 5 years they could cope with the output of the entire Soviet Union in a couple hours. But think about where they were. They talked about this $500,000 supercomputer. In today's money, that's like $1 billion, right? Really big, expensive computer. It has less computation than your phone by orders of magnitude. It probably has less computation than your toaster. It may have less computation than your shoe, right? And this thing could it could barely kind of, output a string. And they're like, oh, next stop intelligence. And it looked so close, and it just wasn't. And when you go around saying that in 4 or 5 years we will have it solved, and then nothing happens for 10 years, for 20 years, people started trying to write down everything they knew because they realized knowledge was important. You couldn't act in the world without knowing something about the world. So you started writing everything down, like, when ice gets warm, it melts. And it turns out there's just an infinite number of these facts, and they contradict each other if you don't write them down right. And it turned out that this basically imploded. So this whole industry that had all of this excitement behind it, there was this decision that actually, you know what? It doesn't work. It didn't work in 4 years. It didn't work in 40 years. It's just a bust. And it's what people call AI winter. People totally lost confidence in the whole endeavor. The AI classes were not filled like this, and there was not an industry presence of any of these technologies. People gave up on it as a pipe dream. Then what happened? In the 90s, people had a kind of change of heart. Rather than using kind of the core tools of logic, which are still important, they started using core tools of probability and statistics. They had a focus on uncertainty, which turned out to be the key thing you needed to manage. Whatever system you built, it wasn't going to be perfect, and it wasn't going to know everything, and you need to be able to balance all that stuff, the stuff you do know against the stuff you don't know. And people started thinking with kind of a much wider range of technical tools, much, much, much better computers, right? And better algorithms, and suddenly we started to have the tools to do something. And some people were declaring AI spring, that maybe things were starting to bloom again.